We're here to talk through this non-consecutive Sudoku by Murat Can Tonta. It has the same pattern as an anti-knight puzzle we already solved, and some of the same starting points. For instance, these ones coming across, eliminate all but the space for a 1. Get another 1 down here. Got 2 2s that have to put a 2 in here, but you can't touch that 3. These 2 3s have to put a 3 over here, but you can't touch that 2. Got a 7 that's going to have to be in one of these cells, and one way when we start to write a note is we think about the digits right near it. So a 6 can't be in either of these cells, so 6 has to be over here. That means a 5 can't be in these cells, so it's got to be over here. And then unmix a pair, which means a 4 is the last digit in that spot. So now we have a 5 near a 4 or a 6, that would be bad. So 7 is in the middle, 5 to the right, 4 down here, and 6 so that we don't form a 7 6 touching. We get a 7 up in this set of cells. We have, it looks like some more we can force in. Actually, we have to get a 3 here, which means this is 5 with 8 9, 8 9, and there's a 6 up top. 4 and 8 in these two cells, but you can't put the 4 near the 8. 5 and 9 in these cells, and the 5 has to dodge both the 4 and the 6. So you get these placements. Coming back now, looking across, we have 2 4s that clear out all this space, but you can't put a 4 near that 3. You still need to get a 2 in the spot, but it's not near that 3. You need to get a 2 over here as well, but it's not near these 1s, so 2 here, 2 here. This 6 is canceling in all those cells, including those near the 5, so 6 is over here. This is then 8 9, this is 7 8, this is 7 9, just looking at the values we have. This is another 8 9. There's probably not as much around these digits. The only force constraint would be 5 near the 6, so I'm now going to be looking into these corner cells, and I guess I'll be taking some digits I see enough of. I see like 2 4s, so I'm thinking about a 4 in these cells. 2 4, so I'm thinking about a 4 in these cells, but there's a 5 up above, so that gives me this 4, gives me this 4. Now thinking about where that limits the next 5, so 5 can be in any of these 3 cells, but that's still pretty flexible. Maybe 3 is a digit to look at, so 3 can't be near this 4, so it can't take this top cell. And it also is now cleared because of these row clues. So only these cells are for the 3, but there's a 4 right there. So actually this has to be a 3, 3. Moves the 4 up quickly, moves this 4 down, puts a 3 in one of these 2 cells. Over here, a 3 is not up above, so a 3 is down here. 3 not in these cells. It is in one of those 2 cells. Still working off this space, this 2 coming across. Now if this 3 place limits all these as being 2, so 2 must be in the top. 2 isn't here, but of these cells it's not near that 3, so 2 is there. Puts in this 2, gets sort of that set of last options. Need a 5 somewhere in the space, and the only thing we clear is this cell. We actually get a 9, has to be up top in this middle row, but it's going to be in one of these cells, so 9's over here. So still somewhat flexible. We do have, though, like this constraint where the 7 is in this column already as a pointing pair, so 7's in one of these cells. This is probably where we're going to start to get some constraints as we work through the rest of the grid. Let's come over here. 5s can't be in these cells, so 5 has to be on the left up top. Means the 5 is down here. Looking at the digit 1, 1 can't be in these cells and can't be near those spaces around the 2, so this has to be the 1, this is the 5. That looks like good progress. It puts a 1 in here, and now means the 5 has to be in these cells. If this is a 5, that means a 6, which is in here, also can't be in the middle because it wouldn't be touching whichever cell the 6 is in. So 6 is here, but if the 6 is there, then the 5 also can't be there. So I think we now have a case where we've eliminated all but the cell for the 5 because it can't be near the 6, can't be here because it's seen, can't be here because there's a 4. So yeah, this is a 5. One of these is a 5, but there's already that above, so this 5 comes in here, puts in this 5. Now dealing with 6s coming across, which means a 6 is in one of these cells. 6 is coming here and here, not near this 5, not near this 5, so 6 has to be in this unique cell, and that gives us one of these 2. 7 and 7 means a 7 is up top or down here, but not seeing the 6. That now eliminates the 7 here, which puts in the 7, puts in this 9, puts in the 6, puts in this 1. That 6 puts in a 7 and a 6, puts in another 6, puts in this 8. That 6 eliminates this option, so last place for a 6, last place for a 6. That moved the 3 note we already had, which puts this 3 down, this 3, 1, like this. That intercepted the 7 and the 9. We have 1 and 8 to go in the space, but the 1 has to be here. This is the last space for a 1. Put in this 8, puts in this 8, puts in this 8, 9, 7 quite quickly, puts in this 9, this 7. Top of this column will have to be 3. We've got 7, 9 to go, but 6 is already in there, so 7 to the right and 9 to the left. Puts the 7 down in the bottom. This is 2, 9, but the 1's up above, so 2's got to go down. Puts in 2, 8, and 8, 9, so we finish this grid. So really, again, just getting used to the anti-constraints, thinking about the space around your notes. I think there was a lot of creative note writing. I was doing this upper corner chart by just marking these 2 4s, but that triggered me to look at both the digits 5 and 3, and it turns out 3 was the magic one, gave me this 3, gave me this 4. I then got back to looking at a 2, get this 2, and then I was like working around this grid. Where did the 9 go? Where does the 7 go? Eventually got to where we had a 6 over here, which pushed a 5 over there. So really focusing on the places you can write the most constrained notes, eventually you'll run into the weird but singular form of a non-consecutive rule that gets you through to the end. So hope you got something through this video. We'll see you again soon.